Hello everyone, this is the second part of the feature engineering techniques in machine learning. So let's start with the first one here is one hot encoding. This is the most common encoding methods in machine learning. Now what happens here, you can see it in the diagram that the color column is converted into separate colors column. Now you can see the rows of red, yellow and green color is separately converted into columns, and we are assigning binary value either 1 or 0 to these columns. Now these binary values express the relationship between the grouped and the encoded columns. It is useful as it can convert the categorical data without losing any information, and most of the algorithms like logistic regression accept these data which we prepare by one hot encoding. The next comes scaling. This is again very important. This is used in machine learning to standardize the independent features which are present in the data, and we standardize them in a fixed range. Now, scaling is done to handle highly varying magnitude of values or units. Now, for example, if an algorithm considers a value like 3000 meters to be greater than 5 kilometers, then it will result in inaccurate results and predictions. So, what happens is, with the help of scaling, we bring all the values to the same magnitude so that they are treated equally irrespective of the units. Now, there are two ways in which we can do scaling. The first one is normalization, and the second is standardization or Z-score normalization. The normalization is also called as min-max normalization. We can see the formula here: x minus x minimum divided by x maximum minus x minimum. This scales down all the values in a fixed range between 0 and 1. Now, there's a problem with this transformation as it does not change the distribution of the feature, and due to this, there's decrease in the standard deviation and the effects of the outliers increases. So this is highly advisable to handle outliers before using normalization. The second one is standardization or Z-score normalization. This scales the value taking into account standard deviation. So this fills the gap which normalization had. Now, if standard deviation of the feature is different, the range would also differ. So it will not have effect of the outliers. And the formula is z is equals to xi minus mu upon sigma. Mu is the mean and sigma is the standard deviation. So we are done with feature engineering. Now in the next video, we will see all you want to know or need to know about SciPy and scikit-learn, the Python libraries. And for installation of Python and Jupyter Notebook, please refer to the website which I will provide the link in the description box. Thank you for listening and watching.